Okay, now, first thing, we've got two different types of angles when we're talking about applications of static trigonometry. Let's say there's a person down on the ground, and that person is looking up at a bird with boots on. Okay, so that person looking up is going to be, the angle of the horizon would be completely horizontal, and the angle of his view is called the angle of elevation because he's looking up. Now, let's say a person's on a cliff looking down at the ocean, and here's a person in a yellow kayak, just like mine. And so the person up on the cliff is looking down. Well, the horizon is still directly horizontal from his view, but when he's looking down then, this is called the angle of depression. So looking up, angle of elevation; looking down, angle of depression. Okay, now I told you the example a while ago about my friend who needed to find the height of the trees on the hospital grounds. Well, this is actually the better technique for doing it. It's what a surveyor would do. What you do is you get back a measured distance from the tree. So you measure this distance, and let's say this distance is 30 feet. Now, you also measure the angle when you look up at the top of the tree. And let's say that angle turns out to be 40 degrees. All right, so now we basically have a triangle, and we're trying to solve for h. So we have the angle, we have the opposite side, and we have the adjacent side. Now, we don't care about the hypotenuse, but what we would say then is tangent of 40 degrees equals h over 30 foot. So now I solve for h. So h equals 30 feet times tangent of 40 degrees. So I crank that out in my calculator. So 40 tangent, 30 times, and that's 25.17 feet. So we'll just say 25 feet. Now, let's say we know that the person looking is looking at a height of 6 feet. So basically the height from here to here is 6 feet. So that means we would just add 6 foot to that. So the tree is 31 foot tall. That's it, piece of cake. So it's really similar to what we've done in the past. We're just solving for triangles given a side and an angle. Okay, let's try another one. Okay, so now, let's say we have a person up on a cliff looking down at a boat. Now, let's say he knows that the cliff is 500 feet high and that his angle of depression is 20 degrees. And what he wants to know is how far out is the boat. So basically, this is what we're looking for right here is the distance that the boat is out away from the cliff. So notice basically what we have is a right triangle right here, and I have an angle and I have this side. So what trig function do I need then to solve for the length that I'm looking for, which is x? Well, notice it's going to be opposite over adjacent. So tangent of 20 degrees equals 500 over x. And that means x equals 500 divided by tangent of 20. Notice if I multiply x over to the left and then divide tangent of 20 over to the right, then I have my x value. So I go 500, enter 20, tangent, divide. And x turns out to equal 1373.738. 1374 feet. So you look at it once again and notice I drew the 20 degrees a little bit too big. So really it should be a little bit further out there, but that's my distance out. Okay, now this time what we're doing is we're looking down at something, like we're looking at a map. So north is straight up, south straight down, east straight to the right, west straight to the left. Okay, so we have a 40-degree angle right here from 0. Well, really what we want to do is talk about that from north. So if it's 40 degrees from east, then it's going to be 50 degrees off of north. So the way we say this is north 50 degrees east. So the first direction is saying that's where I'm starting from, and then the angle is how far it goes toward the second direction. So starting from north, if I go 50 degrees toward the east, then that's where I have it. So this is north 50 degrees east. Now, let's say we have another angle that goes off this direction, and we'll say this angle is 70 degrees. So how would we write the purple? This is going to be north 70 degrees west. All right, now, let's say I have another angle that's down here like this. Now, let's say the measure of the angle all the way around is going to be 260 degrees. So what we really want to know here is how far off south is that? Well, it's going to be 10 degrees because we know south is 270 degrees. So this is 10 degrees in here. And so how do we say this? It's south 10 degrees west. Okay, now, one last one. If we go, let's say 20 degrees off of east. Well, 20 degrees off of east means it's 70 degrees off of south. So this would be south 70 degrees east. Notice the first letter is always either north or south. You're never going to have an east 50 degrees north. So it's north 50 degrees east means 50 degrees toward the east from the north, or 70 degrees toward the west from the north, or 10 degrees toward the west from the south, or here is 70 degrees toward the east from the south. That's it, piece of cake. Okay, now, we have a volcano, and we want to know the height of the volcano, but we can't actually get inside the volcano to find out this height that we want to know. So here's what we do. We go back away from the volcano and measure one angle that goes up to the top. So let's say we make one measurement that's right here. And that measurement is 40 degrees. Now we move back a measured distance. So let's say this is we move back 1,000 feet. And we measure the angle from there. It turns out to be 30 degrees. And so now we have enough information that we can calculate the height of the volcano. Now, the one thing that we need to label here is the distance to the center of the volcano, which is going to be x. Okay, so we have an unknown height of volcano, an unknown distance from the center of the volcano, and what we do know is we have one angle that's 40 degrees angle of elevation, move back 1,000 feet, and the angle of elevation is 30 degrees. So we have two triangles now. Let's look at the 30-degree triangle first. So there's my 30-degree triangle. And what's the base? It's 1,000 plus x. So x plus 1,000. The height is h. And that's all we need to know. We don't care about the hypotenuse. Now let's look at the 40-degree triangle. So here we have h is the height again, and this is the right angle, of course. The base is x, and the angle 40 degrees. So the first triangle, we have the equation tangent 30 equals h over x plus 1,000. And the second triangle, we have tangent of 40 equals h over x. So we have two equations with two variables. So what I'm going to do is I'm going to solve for one of the variables in one of the equations and then plug it into the other equation. Okay, so this one seems to be the simplest. If I just multiply both sides by x, then I have h equals x tangent 40. Okay, so what I'm going to do then is plug that in here. So what I have is tangent of 30 degrees equals h, which is x tangent 40 over x plus 1,000. Now what I need to do is solve for x. Then once I get x, I can plug it back into this equation and get h. Okay, so I multiply both sides by x plus 1,000. So x plus 1,000 times tangent of 30 equals x tangent 40. Now my goal is to get x alone. So what I do is I get all the x's on one side. Well, what I need to do here is distribute. So this is going to be x tangent 30 plus 1,000 tangent 30 equals x tangent 40. Now, if I subtract x tangent 30 from both sides, then I have all my x's on the right. So 1,000 tangent 30 equals x tangent 40 minus x tangent 30. Okay, now I'm trying to get x's alone, so I'm going to factor out an x on the right. So 1,000 tangent 30 equals x times the quantity tangent 40 minus tangent 30. Okay, now I just divide out the parentheses and I have x alone. So x equals 1,000 tangent 30 over tangent 40 minus tangent 30. Okay, now, if that's what x equals, then h will equal x times tangent 40. So it's going to be 1,000 tangent 30 times tangent 40 over tangent 40 minus tangent 30. So notice what I've done is I've just taken the one equation with h equals something with x in it, plugged it in. Now I have just x's alone with no h in there. So then what I do is I multiply the x plus 1,000 over, distribute it. Now I'm going to get all my x's on one side, all my non-x's on the other. Then I divide out everything but the x, and that gives me an expression for x alone. Now everything here is numbers that I can simply multiply out in the calculator. But the thing is, I don't want to know x. X really isn't important. What's important is h. So I know h equals x times tangent 40, so all I do is multiply this thing by tangent 40, which means I put the tangent 40 in the numerator. Now I'm ready to calculate the h, and so all I do is punch that out. So I have 1,000, enter, 30 tangent times 40 tangent times. Now I'm going to divide by 40 tangent, 30 tangent minus divide. So there I have h equals 1850.833. So h is approximately 1851 feet. Now, once again, you look at the drawing. If this is 1,000 feet, then it makes sense that this would be 1851. So I've calculated the height of the volcano without actually needing to go into the heart of the volcano. So that's very good. That's it. Game over. Have fun with these.